Rather than working with the sort of distribution-based idea we saw in the last couple of examples, we could instead take a different tactic and make a thing called a stem and leaf plot, where we look at breaking up numerical data in terms of digits. The most common representation we have for something like this is with two-digit numbers, where we call the tens place the stems and the ones places the leaves. Where if you have a number like 21 in your data set, whatever you might be measuring, maybe that's the length of arms, I don't know, is the first thing that came to my mind, you would have 2 as the stem. In this case, 1 would be a leaf. And then if you got someone who's 22, you'd have a 2 there. If it was no 21, you'd have a 1 there. But you get the idea that you're breaking the things off by tens, and then the number of things inside of them, where it's kind of hard actually to describe what a stem and leaf plot is. Really, the easiest way to understand it is to just see an example construction. For this, you want to use the data below for a stem and leaf plot, where yet again, I'm going to be too lazy to read all of those numbers. And what we could do with this is look at all of these values and first identify what the biggest and smallest are in there, where we can see, hopefully, a 47 hidden in there. It is in the first row and second column. And as well, we have a 93, it looks like, in here, at the very least in our first row. It seems like if you really dig in there, you can get some bigger ones, like there's a 94 hidden in there somewhere. And what we could do with that is turn our first row into the rough idea of what a stem and leaf plot is going to end up being by taking our values in the 40s, 50s, 60s, 70s, 80s, and 90s, and more or less breaking those off into categories that we call stems, like so, and then pulling out the leaves, the number of values that come up after in those categorizations, I guess you could say, where because we have a 47 in the leaves, we would get a 7 to go with the 4. Then, because we have a 57, a 7 would go with the 5. Because we have a 64 and a 63, we have a 4 and a 3. Because we have a 75, we get a 5 after the 7. Because we have two 82s, you get two 2s. Because you have a 93, you get a 3. And then we can go from there to fill in the rest of the table as we have here. Again, the idea is breaking the set down in terms of those values, in terms of the tens digits and the units digits, to get a picture like this, which helps a little bit more for categorization, but I'm not a huge fan of stem and leaf plots, because, I don't know, it's still a pile of numbers to me. I don't feel like you did anything particularly useful, but, well, stats books tend to like them a lot, so I'm including it in here. Anyway, these are our main representation you're going to get in this section, but before we move on to some more material for how we make our interpretations, that is, what sort of measurements we can look at with our data to be able to tell a story, we should take a moment here to talk about how things like this, well, they don't necessarily have to be telling the truth.